So this right here, this is a complete children's story. The story, the illustrations, the narration, all of it generated from one API call, just under 2 minutes. But here's the thing, every time the AI generated a new image, it forgot what the character looked like. Same story, completely different character. Different face, different outfit, sometimes a completely different animal. Here's how I actually fixed it and what's really happening behind every story. So on paper, simple. Generate a story, add images, add narration, done. Except it wasn't. What I actually had to build were 3 separate systems that all had to work together. First, I needed structured story text. Not just a paragraph, a full structure with a title, multiple scenes, and a moral at the end. And it had to come back as clean JSON. JSON is a structured format, labeled fields that the backend code can actually read and use. Second, I needed scene images, one per scene, and the characters had to look consistent across every single image, which turned out to be harder than I expected. And the third thing was I needed narration. Not a robotic voice reading lines, but something that actually sounds like a storyteller talking to a kid. Each one of those is achievable on its own, but getting all 3 to work together reliably is where things got complicated. And then the data structure started growing. At first I thought I just needed 3 fields: title, paragraphs, moral, that was it. Then I added a cover image, then person images, then person audio, then moral audio, then title audio, and so on. What started simple became deeply nested very quickly. And that nesting is actually what makes the system resilient. Because each piece can fail independently. So if audio fails, the images are already saved. Nothing is lost. Let me show you what one finished story looks like inside MongoDB. As you can see here, it all lives in one MongoDB document. Every scene has its own image and its own audio, plus a cover image, a title narration, and a moral at the end, all from one API call. The platform I chose for this entire pipeline is Google Gemini, and specifically 3 different Gemini models: Gemini 2.5 Pro for the story text, Gemini 2.0 Flash Preview for the images, and Gemini 2.5 Pro Preview TTS for audio narration. 3 different models, 3 different jobs. Let me walk you through each step and show you what broke and what finally worked. Step 1 is getting the story text. Before writing any backend code, I tested everything in Gemini AI Studio first. It's just a browser interface where you can type prompts and see responses instantly. It's way faster than running the full pipeline every time you want to try something. So my very first attempt looked like this. There was no structure, no format, no instructions, just write me a story. And this is what came back, a wall of text. And here's the thing, that's not Gemini getting it wrong. That's Gemini doing exactly what I asked. I asked for a story, I got a story. The AI follows instructions, which means if your instructions are vague, you get vague output. If you are specific, like telling it the format, the fields, the structure you need, it gives you exactly that. So I rewrote the prompt, like write me a story in JSON format with a title, paragraphs, and a moral at the end. And that worked. Now I was getting something I could actually use. When I'm testing a prompt, I'm in AI Studio, not in my terminal, not running the full backend. The reason for this was when something goes wrong, you need to know if it's the prompt or the code. AI Studio separates those 2 problems. You paste the prompt, hit run, 10 seconds. If it comes back wrong, it's the prompt. If it comes back right, the bug is in your code. I still use this today. Before I change anything about story generation, I test the new prompt here first. Only when the output looks right do I touch the code. So here's the prompt that AI follows to generate a story. 144 lines. The prompt does a lot of work. It writes the story, breaks it into scenes, builds an image prompt for each one, applies age-appropriate vocabulary. But 2 things hidden inside here changed everything: a character sheet and a generation seed. But this prompt didn't start this way. All of this experimentation happened in AI Studio first, not in code. I would type a prompt, see what comes back, tweak it, and test again. Only once the output looked right did I move into the backend. There were a lot of small iterations in the prompt along the way, but these are the 4 that actually changed the output in a meaningful way. Version 1 was barely a paragraph. like write a children's story with a moral. That's almost what V1 was. I got a blob of text back, like with no structure, nothing I could use. Then for version 2, I added the JSON schema. Now I was getting structured output, but the same character looked like a completely different person in every scene image. So in version 3, I added the character sheet and the generation seed. This turned out to be the key to consistent images. Things got better, but I was still seeing the model use she and he in image prompts, and the character kept drifting. I'll show you exactly how the character sheet and seed work in the next section. Then in version 4, I added the no pronouns rule. Rules to prevent characters from duplicating images and safety filters to make sure nothing inappropriate gets generated for kids. And that's the version the app is running on today. So here's what inside the prompt. Step 1 is generate a random seed, the consistency anchor for everything after. Then step 2 is determine story type, theme based or custom. Then step 3, write the story text, vocabulary, sentence length, pacing, all based on the age. Then step 4, build a character sheet, the visual specifications for every character. Then in step 5, break the story into paragraphs, write an image prompt for each one. Then in step 6, apply image prompt rules. I will cover all these things when we get to images. Then the last step is step 7, create the cover image. It has its own separate rules from the scene images. Two fields in here that are the most important parts of the prompt, character sheet and generation seed. Neither of them is for the story text. They are entirely for the images, generated here in the text step because the image pipeline depends on them completely. The character sheet is a detailed physical description of every character in the story, like eye color, hair color, clothing, height, the specific details that the image model needs to stay consistent. Then generation seed, which is a random number between 1 and 1 million. But here's the part. I don't generate this number. Gemini does. The AI picks its own consistency anchor as part of writing the story. And this is all automated. So as soon as the text step completes, the backend reads that seed out of the JSON and carries it forward into every image prompt that follows. The text step generates it, the image step uses it. So it's like the model that wrote the story is setting the visual consistency rules for the model that draws it. The other thing I had to get right was age-appropriate content, because the story for a 3-year-old is genuinely not the same as a story for a 6-year-old. So age goes directly into the prompt as a parameter, and that's what tells Gemini how to write, what vocabulary to use, how complex the sentences can be. Separately, I also sent a minimum and maximum age range that gets stored in the database, and that's purely for filtering stories for age group in the app. 2 different fields, 2 different jobs. And since I'm the one generating stories, I'm also the one deciding which age group to target and what vocabulary constraints to apply. I was also very intentional about what the stories are actually about. Every single story, regardless of age group or difficulty, is moral based. Every story has a key takeaway for the child, like how rain forms, what happens when you find trash on the road, why plants need sunlight. These are topics kids actually encounter. Even the superhero category, which I was very deliberate about, none of the stories are about frictional powers. They are more grounded in reality, like helping a friend who is anxious is also a superpower. And the animal stories are built around themes like saving or adopting an animal, something with actual emotional weight for a kid. That was my decision as the creator. The AI generates the story, but what kind of stories this app makes was decided before I built any of this. All of that plus the vocabulary limits, sentence lengths, what's appropriate for each age gets passed into the prompt as a parameter called content guide, a full block of text the AI reads before writing anything. The content guide is not just a setting I filled in randomly. So before generating a single story, I built out a proper framework. Exact sentence word count per age group, how many scenes, what plot complexity is appropriate, grammar rules, even example sentences showing the vocabulary level I expected. I used ChatGPT and children's literacy resources to build this, and the difference between levels is dramatic. Take the same theme, say science. For a 2-year-old beginner, versus a 6-year-old advanced. The 2-year-old version gets very short scenes, like 4 to 6 lines, onomatopoeia, colors and shapes, simple cause and effect. The 6-year-old advanced version gets longer scenes, similes, the same scientific concept explained properly but in an engaging way. Same pipeline, completely different story, just from changing the content guide. The other thing baked into the story prompt is content filtering. Because this is a kids app and I needed hard rules in there. So no scary content, no dark themes, no violence. Only positive outcomes, only safe and uplifting stories. Early on, I would send a theme like a lion and a rabbit, and instead of a story, I would just get an error back. What I didn't realize at first was what was actually happening. Gemini was generating the story but writing the natural version of it. The lion hunts a rabbit, a predator and a prey story. Because that's actually what a lion and rabbit are in the real world, right? And that predator-prey dynamic is what triggered Gemini's own safety filter. It scanned the output, flagged it as inappropriate for children and blocked it. So the story was being created and immediately rejected before it ever reached me. The content rules fix that. They tell Gemini what kind of story this is before it starts writing. Once the prompt was solid, the text generation actually worked really well. Clean JSON back from Gemini 2.5 Pro with title, paragraphs, each paragraph with its own image prompt already built in, the moral at the end and the character sheet and scene sitting there for the image step. Now the text was working and then came images. Images were the hardest part of this entire project. Look at this, same character, 3 scenes. In scene 1, the eyes are slightly off. Something just feels wrong about the face. In scene 2, normal eyes, looks right. And in scene 3, same character but there are 2 of her in the same frame. AI's way of showing the character doing 2 things at once, it just drew the character twice. So here's the core problem. Every single image generation call is completely independent. The model has no memory of what it generated 2 seconds ago. No context, no reference. Every call starts from absolute zero. So for a 5-scene story, I was making 5 totally independent calls and each one came back a little different. The text pipeline worked, the structure was clean, but the character kept changing between the scenes. So I stopped running the full backend and went back to basics. Opened Google AI Studio, the browser interface, took the JSON from step 1, the character description, the scene text and pasted it straight into the prompt box. Tweaked it, generated and tweaked again. That way I could test in seconds instead of waiting for the entire pipeline every time. But before I could tackle consistency, I needed to pick the art style for the images first. I tested at least 10 styles. Each one had something going for it, but none of them felt quite right for a kids app. What I landed on was soft, friendly children's book illustration, warm colors, clean shapes, gentle lighting, character that feel approachable to a 2-year-old, and that was the right call. So I logged this style and from that point I added the style instruction directly inside every single prompt, like soft children's book illustration, warm colors, clean shapes. Every call, every scene, that part stayed consistent across all of them. Now I had to solve the character consistency problem. Character consistency. All of it came down to what was inside the image prompt itself. I started simple. Just add the character description. Something like a young boy with brown hair wearing red shirt and black shoes. That one line in every scene's image prompt. I generated a 5-scene story and looked at the logs. The same character description was going into every single scene's image prompt. Identical, but when I compared the images side by side, 5 different characters came back. So I started adding more details to the character description, like eye color, hair, clothing, height, all of it specific. That helped, but the model only follows what you tell it. Everything you don't specify, it decides differently every call. So I would specify the face, then face was consistent, but the jacket was a different length by scene 3. Then I would add the jacket, then face fixed, jacket fixed, but now the shoes were inconsistent. Then I would add the shoes, then face fixed, jacket fixed, shoes fixed, but now the height ratio between the characters was off. It wasn't that fixing one thing broke another. It was that the model needed specific instructions for everything, and I kept finding things I hadn't thought to define yet. You can't sit down and write the perfect character specifications from scratch. You don't know what to specify until you see it break, and that's how the character sheet grew. I didn't know it at the time, but apparently this is what prompt engineers call iterative prompting. Fancy name for try it, see what breaks, fix it, and repeat. On top of the character sheet, I also added a set of rules directly inside the image prompt. Some were there from the start, some I added after seeing something break. Rule 1 is no pronouns. When Gemini was generating the image prompt inside the pipeline, it would sometimes write things like, "She runs through the forest." Now the image model then has no idea who she is. It guesses, and it guesses differently every call. So I instructed it. Every character must be referred to by their full name and description, exactly as defined in the character sheet every single time. Then the next rule was one character, one body, no duplicates. This one covers two things. First is no duplicates. Early on, images would show the same character twice in one frame, the model's way of showing movement. Once I saw it and I added this rule, then it stopped. Then the second thing is no extra limbs. When a paragraph had multiple things happening, say the character was eating fruit and then waved at a friend, the model would add a third arm to show both actions. Then the rule third is camera angle and lighting. This one is intentionally different. It's not the same for every scene. Like morning scene gets morning light, indoor scene gets indoor lighting. It adapts to whatever the paragraph describes. All of these go into every single image prompt call. And then the thing that actually tied it all together, that character sheet, the one we just built. I started injecting the whole thing into every single image prompt, and the generation seed, that random number between 1 and 1 million that Gemini picks. I started injecting that into every prompt too. So now the character sheet plus seed, that was the fix. And you can see it, same character across every scene. That's the generation seed and character sheet working together. Now you might wonder, is it perfect? No. You will still occasionally get a scene where something is slightly off. But it's not fully in my control. I'm still working on improving it. And that's just how it is when you're building with AI. In the pipeline, the images generate sequentially. Like cover first, then scenes one at a time, not all at once. I tried generating them in parallel, but Gemini hit rate limits. Some calls succeeded, others failed with errors. So I ended up with a story where some scenes had images and some did not. Sequential is slower, but every call completes before the next one starts. So there is no partial failures. And if an image call fails entirely, even in sequential, the backend substitutes a placeholder so the story still saves rather than crashing. Since I'm the one generating all stories, I just delete it and regenerate. So it never goes live with a placeholder.
The sun peeked into Neela's room. It was a happy, sunny morning.
That's the voice narrating every story in the app. I tested several voices in AI Studio and landed on Autonom, exactly what Kate's story needed. And on top of that, I added a prompt instruction, telling the model to narrate like a theatrical, high-energy storyteller. The voice plus the prompt, that's what makes it sound the way it does. Right now, every story uses Autonom, but the schema is built to support more voices, sound effects, and background music. All things I'm planning to add later. Now audio runs last. Once text and images are saved, it kicks off automatically, generating audio for the title, every scene, and the moral. If Gemini TTS fails or hits a quota limit, the iOS app falls back to Apple's built-in TTS. Kids get narration either way. Apple has a built-in TTS engine on every iPhone. You might wonder why I didn't just use it from the start. I tried. It's good, but for a kid's story, it sounds robotic. It reads the words. It doesn't tell the story. On the other hand, Gemini's Autono voice is the difference between a narrator and a text reader. The Apple fallback is there for reliability, not quality. Gemini TTS returns PCM audio, which is pulse code modulation. It's nothing but raw, uncompressed audio. Before it hits Cloudinary, FMMP, which is a free open source audio and video converter, converts it to AAC, which is Advanced Audio Coding. It is a compressed, smaller file, faster loading on any device. PCM is what Gemini hands back. AAC is what actually gets stored and served. That conversion happens automatically in the backend before every upload. If audio fails, there is also a retry endpoint. Pass it the story ID which you find on MongoDB, then it reruns only the audio step. Text and images stay untouched. The story saves to MongoDB before audio even runs. So if audio fails halfway due to quota limit or network timeout, the story is already there. The retry endpoint fills in what's missing. The pipeline doesn't crash, it just picks up where it left off. Earlier, I would just delete the entire story when audio failed. Building this endpoint changed that completely. Now let me show you the whole pipeline running. Curl is a tool that lets you talk directly to the backend just by typing a command in your terminal. So let's look at the actual command. A few flags. Each one does something specific. -X. This tells the backend I'm sending data, not just asking for it. Post means I have something for you. Then -H. That's a header. I send to. The API key, which is the security pass that proves this request is coming from me, and the content type, which tells the backend the data I'm sending is formatted as JSON. Then -D. That's the actual data I'm sending, what the pipeline needs to run, like the basics which include age range, theme and difficulty level like beginner, intermediate or advanced. Then two optional fields I always include. First is user prompt. I use this to give the model direction. What kind of story I want, what characters, what situation. It keeps stories varied within the same category instead of getting repetitive. Then the next is content guide. This one I have defined myself for each age group. How many sentences per paragraph, word complexity, how long the story should be. The model uses it to match the story to the age. And that's everything the pipeline needs to start. One command, watch what comes back. That response means the story was successfully generated with text, images and audio, all from just one command, and it typically takes 2 to 3 minutes. But since I pre-generate everything, users never wait. Now let me show you what actually happened on the backend while that was running. Story request hits the backend. Gemini 2.5 Pro starts generating text. Text comes back, JSON passed. Character sheet extracted, the full visual specifications for every character. Then generation seed set. From this point, both the character sheet and the seed gets injected into every single image prompt that follows. Then cover image generation starts first. Once cover is done, now scene images one at a time sequentially. Now images start uploading to Cloudinary. Story gets saved to MongoDB. And this is what one story looks like inside MongoDB. Cover image with its image URL and audio URL. 5 scenes, each with its own image and its own audio. The model at the end with its own audio. Everything nested inside a single document. This is what that one curl command produced. And as you can see, everything is nested. Now audio starts to generate. Last piece of the pipeline. This is where it's narrating every scene one by one. And there is one more thing that happens automatically. When a story gets generated for a theme that doesn't exist as a category yet, the backend doesn't just save the story. It spins up an entire sub-pipeline to create the category too. Gemini generates the category display name, a description, a color, then a full background illustration for the category card, and a category icon. Everything you see in the category grid in the app, those background images, those icons, all are AI generated.
In the warm, sunny savannah lived a tiny elephant named Noor. She had soft gray skin, bright blue eyes, and the biggest, floppiest ears you ever did see.
There is no generate story button in the iOS app. Stories are pre-generated by me, the developer, and stored in MongoDB. The iOS app is a reader. It fetches what's already there and displays it. Worth explaining the design decision here, because it's not obvious why I went this way. Why not let users generate their own stories on demand? There were 4 reasons. First is cost. Every generation is a full pipeline run with text, images, audio. So if 1,000 users each triggered one story, that's 1,000 complete Gemini pipelines. The cost scales directly with user count. Pre-generating means I decide the pace and I control the cost. Then second is quality. I always review a story before it goes live. User triggered generation means whatever the AI produces goes straight into the app with no review step. For a kids app, that's not something I was willing to do. Then the third is latency. Users open the app and stories are instant. No one stares at a loading screen for 2 to 3 minutes. The heavy lifting is already done. And the last is rate limits. Gemini has API quotas. So if multiple users trigger generation at the same time, it could hit quota errors mid-pipeline and fail. So pre-generating gives me full control over the piece. So now let's talk about the challenges that actually broke the pipeline and how I fixed each one. Challenge 1 was JSON parsing. Gemini is supposed to return pure JSON, but sometimes it wraps it with extra text before or backticks around it. The parser hits that and crashes. This happens right after Gemini returns the story text, before images, before audio, before anything saves. The entire pipeline stops before anything else can run. The fix for this was a regex that strips those backticks and any surrounding text before the parser ever touches it. It doesn't matter what Gemini wraps around the JSON, it gets cleaned first, then parsed. It works every time. Challenge 2 was content filtering. Before I added content rules, Gemini's own safety filter would block the response mid-generation and return an error, not a story. The fix was telling the prompt upfront, no sensitive or explicit words to be added in the story, and that stopped the safety filter from triggering in the first place. Challenge was rate limits mid-pipeline. This one wasn't really in my hands. Gemini has its own API quotas and sometimes just says too many requests. The fix was generating images one at a time instead of all at once, so the pipeline never floods the API. Text and images saved to MongoDB together once everything is ready. Then audio runs after that. So if audio fails, the story is already saved. Then the challenge 4th was render free tier timeouts. Once the app was live, the free tier server would spin down after inactivity, and a 2 to 3 minute pipeline on a server that just woke up from a cold start would hit the timeout before finishing. Stories just wouldn't generate. The fix was $7 a month render starter plan that keeps the server running at all times. Sometimes there is no elegant solution, right? You just pay the $7. So that's the full AI pipeline with text, images, audio, one API call, sequential, resilient, stored in MongoDB and served to a SwiftUI iOS app. 3 AI models, 3 different jobs, and 1 complete product. So in this video, we covered how the story text gets structured, how I worked on character consistency across images, and how audio narration works, and the whole pipeline runs from a single command. One thing I want to be clear about, that there is no fixed template here. What worked for me might not work for you. The character sheet, the prompts, the generation seed, I didn't get any of it right on the first try. It took weeks of experimenting. And honestly, that's the part I enjoyed most. Every failure taught me something I wouldn't have learned any other way. I don't share these videos to say follow my exact steps. I share it so you can see how someone figures it out and maybe use that as a starting point for your own projects. Next video is the iOS app, how it looks, how it works, how authentication works, multi-profile support. So if you haven't subscribed yet, make sure to subscribe and hit like. It genuinely helps the series to reach more people. So that's it from me guys. See you in the next one. Until then, bye-bye.